Yesterday we heard from the Duran Company. Tomorrow we're going to be visiting Missouri Cobalt. And now we're going to be hearing from the third major player when it comes to mining in the state. We're going to be hearing from Jim Kennedy from Caldera Holdings.
Thank you, everybody. John, can you figure that out? I think I broke it. So we're going to be talking about a mine that's literally 40 miles from right here. The Pea Ridge mine was shut down in 2001. There's 40 years of accumulated mining waste in the tailings. And what we discovered over the years is it also happens to be one of the best sources in the world for not just rare earths, heavy rare earths, and a number of high-value co-products. You got it going for me? Thank you. All right. I'm really supposed to be giving you an update on some other stuff, so I'm going to try to do both. What we're going to talk about is the status of rare earths, some things you may not understand, and a solution. Okay, so there's 16, not 17, there's 16 commercial rare earths. Promethium really doesn't exist anymore in the Earth's crust. Out of the 16, 5 of them represent 90% of all value of all rare earths on the planet collectively. The rest have very little value, and in fact, for cerium and lanthanum, they have a very negative economic value on the process cost in rare earths. So the miracle of rare earths, they do a lot of really incredible things, but deployed in the world, the big thing they do is they provide for the NdFeB magnet. The NdFeB magnet is 35 times stronger than an old magnet you played with when you were a kid and you picked up iron filings. The problem is that magnet is not stable as it gets hot. So very few people understand this, but if I make a standard NdFeB magnet and it has no doping, at about 80 degrees C, it starts losing its strength. So you get your brand new Tesla and you've got your NdFeB magnets there and you're going to go down to the grocery store, your third stop sign, your brakes don't work and your motor doesn't work because it's too hot because the batteries have overheated. And the only way to fix that is to dope them with terbium, dysprosium, or holmium. Now there's a huge problem there and we'll get to that in a second. But here's another way to look at it. A regular NdFeB magnet with no doping, that's over here. It's not even on the chart. Why is it not on the chart? Because its commercial uses are very limited. It's mostly for novelties and toys. As you add more and more terbium, dysprosium, and holmium, the magnetic stability increases, and you can see the value of the uses increase dramatically. So, at one end of the scale, you've got magnets for your computer. At the other end of your scale, you've got aerospace and defense applications. And so here we'll get to the problem. So the real world, this is the real world. The number one supplier, miner of rare earths in the United States is MP, formerly Molycorp. And they have zero, the number 0. They have 0 recoverable terbium, dysprosium, holmium. That's a fact. No matter what they tell you, that's a fact. Linus, the other allied friend-shoring rare earth supplier, has tiny amounts. And, that's great. They have them. What does it mean? It means a lot for them economically, but geopolitically it's meaningless. And then the other problem is they can't separate them. So what do? They ship the terbium and dysprosium off to China with the samarium, gadolinium, and samarium. China does all the separation. So basically China controls the entire world's ability to develop high-value, high-temperature magnets. Nobody talks about this because the groups that have this problem are not going to draw attention to their failings. So what does this mean in the real world? In the real world, it means that they are very economically vulnerable as a resource supplier. In fact, right now, according to Benchmark Capital, every single rare earth producer outside of China is losing money because their resource distribution is either exclusively NdPr or mostly NdPr with tiny amounts of heavy rare earths to carry them. But they're all basically losing money right now. Another issue that goes on that nobody really talks about is because China sets price. China's the biggest user, the biggest producer, controls all forms of refining, and they actually set price. It's a Chinese index that tells us what prices are. So one of the problems is samarium, part of samarium cobalt magnets, which is a legacy magnet that is still widely used in U.S. systems. Every single bit of separated samarium on the planet comes through China, so you can't build an F-35 or anything else without China essentially allowing it to happen. Okay, I'm going really fast because I got a lot of slides. So here's the problem from a policy perspective. Deficient producers have controlled policy for 15 years. And there is no amount of money that can fix the deficiencies in these resources. So it's a dead end. But what happens? They go out, they apply for funding, they get the funding, they have all the investors behind them, they have everybody tied to their share price. But ultimately, these are three-legged racehorses, and they can never win. They're never going to cross the finish line. But the good money follows bad, and alternatives don't get supported. So let's look at it again. This isn't my data. There's a little group of guys. It's the USGS. I don't know how credible they are, but they publish a lot of data, right? And here we are. This is just bold-faced fact that has been ignored by the Pentagon, by the Department of Energy, investors for almost 2 decades. MP Materials has zero. The number is zero. It doesn't change. It's zero. They have zero recoverable heavy rare earths. Therefore, you can never, ever, ever make a high-temperature magnet for high-value applications unless they're sourcing from China. Linus, to their credit, they've got some of it. It's a very, very small amount, and it means a lot to them economically, but from a geopolitical standpoint, again, it's meaningless. Now, Bionobo, tiny amounts, but it doesn't matter because that is the single biggest producer of rare earths in the world. So when you measure production, Bionobo dwarfs everybody else in the world on this. Okay, well, there's some good news on the horizon. In fact, it's just 40 miles from here. The Pea Ridge mine for 40 years beneficiated the iron ore, stripped out the phosphate because it makes for really bad steel, and they dumped all that phosphate mineral in the tailings lake. And so we went in and did a lot of work, and the USGS came out and helped us do a lot of work. All of the real work, the heavy lifting, was done in the late 70s and early 80s by the U.S. Bureau of Mines. Bring back the Bureau of Mines, please. So what we discovered is that inside the tailings lake, in an easy-to-recover mineral, a phosphate mineral apatite, there's 120,000 tons of rare earth elements, right? And in there, you have really, really nice numbers for terbium and dysprosium, and it's a great deposit, but it's got a limited life. The good news is you use the cash flows and the profits from processing this, and then you go back underground and you start producing iron ore again, and then you will get a discrete phosphate rare earth stream reporting back to the same facilities you built, and then you'll also be able to develop the breccia pipes, which are quite famous, one of the highest value heavy rare earth deposits in the world that is not ionic clays, and that's a whole nother issue. So this is on the very near-term horizon. Here's an independent evaluation, a third-party evaluation, showing the value of a lot of rare earth mines, and this is the concentrate. What's interesting is if you just look at the 4 permitted mines, Pea Ridge's concentrate is about 40% higher, and that is just the concentrate in the rare earths. It does not measure byproducts that you get in the process. And so This is a little bit complicated, and I produced this for the Department of Energy. But what we're talking about here, when I say hot metals, I'm talking about high operating temperature magnets. And if you look at those and their uses, we're basically going to digest and crack 2 minerals. And from these 2 minerals, this is how many boxes we check. It's really quite impressive. Now you're saying, Jim, there's no way you can't do that. Once it's digested and it's in an SX system, solvent extraction system, yes, you can. Every single, if you built the cells for it, mixer settler cells for it, you can drop out every single one of those. And by the way, our tellurium in the pyrite runs between 10 and 15 parts per million. And from the presentation from Rio Tinto last year, their concentrate was 1 part per million. So this is kind of cool. The only thing that matters is high temperature magnets. If we took our material and only our material, this is what we could do. The colors are phases, phase 1, phase 2, phase 3. That's all we can do, though, because we don't have enough praseodymium or neodymium. But we do have Linus and we do have MP, and they produce quite a bit. And basically, a large percentage of that ends up in China. We could acquire NdPr from them or any of the other friendly folks. And then our production numbers are really quite astounding. So, in fact, we could easily produce all the M magnet production, U.S. production for the U.S. Easily. So it is meaningful. The trick for us, which isn't in this presentation, the trick for us is after phase 2, phase 3, we are in the process of acquiring a NRC license. And once we have the license, we'll work with the Thorium Energy Alliance and the Thorium Corporation, and we'll start importing, bringing in the mining waste from other projects that has elevated levels of rare earths and thorium, and we can significantly increase that phase 3 number. There's a lot of mining waste that is very, very rich in heavy rare earths. In fact, the more heavy rare earths you have, the more thorium you're going to have, thorium and or uranium. So what we would be able to do is solve the heavy rare earth issue and then produce a product that can be put on the market for the growing demand in thorium. Okay, some interesting things about Caldera. From a mining standpoint, we are fully permitted. And we are literally, in this week, it was supposed to be January, of course, but this week we're supposed to finish up our NI 43-1. We have geopolitically significant levels of the heavy rare earths. We have all the heavy rare earths. This is probably the single most important thing. We are negotiating the transfer of full spectrum separation. We will build a full spectrum separation facility on Pea Ridge, and we will have engineering guarantees for this. So instead of producing terbium, dysprosium, holmium, samarium, gadolinium, and europium and shipping those off to China to be separated, they'll be separated right here. A little surprise for everybody, according to, studies, Linus, MP, and everybody else is losing money right now on NdPr. It's pretty much their only product. We're just finishing up our proformas, and the heavy rare earths alone carry us. We're still profitable. And then when you add in the byproducts, we remain strongly profitable. And so outside of China, we're literally the only potential rare earth producer that can withstand, the Chinese monopolistic practices, because we have about 5 commodities coming out of there, and some of them are really basic, like fertilizer. And it will produce the phosphate. We have very, very good extraction and recovery levels for the phosphates, and some other products end up rounding out, providing what we would call, nothing certain, but the highest probability of profitability. Another interesting thing about the Pea Ridge project is the pyrite that we're going to recover has very attractive levels of cobalt, nickel, moly, tellurium, and we will produce enough cobalt and have samarium that we could literally meet 100% of U.S. demand for SMCO magnets. And let me say again, every single military piece of hardware using an SMCO magnet, that SM came from China, and the cobalt was probably refined in China. Now, here's an unfortunate thing. The CapEx is so extraordinary that we will definitely need help from the Department of Energy and the Department of Defense. The technology that we're building, that we're acquiring, it's not new. It's not a silver bullet. This is the stuff that the French and the Japanese and the Americans developed in the late 40s. This is the technology we shipped off to China in 1980 when the IAEA and the NRC changed regulatory threshold rules for nuclear source material. And that's how the entire rare earth industry was transferred to China. So the only place in the world where people know how to do that old-fashioned SX technology is China. Our partner contracted with Chinese technology companies and then Chinese nationals who then came in and became residents and taught this group how to do the SX technology. The technology we're going to deploy is going to have 1,500 mixer settlers. The building 100-foot wide and 700-foot long, and we're going to have mixer settlers on 2 different floors. The solvent for the solvent extraction there's so much of it, it'll literally be an entire unit train of solvent. The setup on this is incredibly expensive, and we're going to need help. And I have to say that our good friends over here at MS&T have helped us out in some of our applications, and we really do appreciate that. So here's a picture of what we're really talking about. That doesn't look very big, but that's everything. That's 800% more than Linus, and it's infinitely more than MP. This empty box represents all the other heavies. There's all the other heavies. The only heavy that MP has is yttrium. Yttrium is a very important rare earth, but its economic, its price, its market price exceeds the cost of separating it. And then these are the things that this is the base core metal for the NdFeB magnet. And so you can see we're kind of right in between the two, but this is the big difference for us. So in one of our reports to the Department of Energy, they ask us to discuss market risk. The single greatest market risk for anybody in the rare earth business is how to protect themselves from Chinese monopolistic practices. And it's been said earlier in this room that China doesn't do anything at this market, supply and demand. They are market, they are supply, they are demand. They control price. And by the way, Chinese rare earth to make a, they don't. They're sponsored by the government. They're state-sponsored organizations. They can run for years and years with no profit. That's the difference. And that's a whole, I wrote a paper on that, happy to share it with everybody. But the single most important thing is you have to have a way to be economically viable in the face of China's incredible market power. And we're going to do that, interestingly, through vertical integration. A number of times we've tried to just step one step down or 2 steps downstream, and we always hit resistance. Finally, we just said, well, let's go to the end of the stream and let's go right before the OEMs. We're having discussions right now with EV drive motor fabricators who came to us because their clients, their customers told them, you prove you can eliminate China from the value chain, and if you can't, we will fire you. We will cease to do business. So they're desperate. We are the only source that they found that has the TBDYHO. We're the only source that is going to be able to do the separation. So what we're doing is we're going to partner with an EV drive motor fabricator. They are going to select the magnet fabricator of their choice. They're going to select the metallics fabricator of their choice. And everybody's going to operate under a single JV agreement so that if there is such a thing as a premium for being compliant, if there is such a thing for producing a product where you can prove that it was made at the highest standards and you have blockchain confirmation of every step of the way and every gram, if there is such a premium, it can be distributed back. And why would the EV fabricator agree to this? Because everybody who cares to know knows that every ND-FEB magnet fabricator operating outside of China is losing money. They are non-competitive. The Department of Energy came to this conclusion about 2 years after I did. But what happens is we're going to have to be, if we want that fabricator to operate in the US, maybe in Missouri, we have to guarantee them profitability. The other thing is diversification. We covered that. You know, what's important, I think we covered this pretty well. You know, the downstream process for rare earths is really pretty complicated, and this is really pretty simplified. But, you know, here to start with, if you don't have TBDY in your resource, you're really kind of wasting your time. You're still captured. When you get to midstream, this is the exact point. This is the point of the fulcrum where China has all of its leverage. You can't separate, then you really don't have anything. China controls everything. We are closing out on the details on this, and once you get this solved, the next point at which China has a leverage control point is in the manufacture of the magnets. The Department of Energy determined that no one can profitably or competitively make an ND-FEB magnet outside of China. That's why every magnet manufacturer in the world is abandoning facilities someplace and moving into China to fabricate. Again, how can this happen? How can the value of something here go to zero here? Well, they control prices, they control everything. I wrote a paper on it and invite you guys to read it or request it from me. And it is extremely detailed, and it lays out exactly why this entire thing is a giant rat maze with a cleaver at the end to kill you. There's just no way you're intended to survive this. Speaking earlier, if you want to take on China and you want to compete in critical materials, you're never going to win unless you understand why they're winning and you're losing. So I invite you guys to read the paper. But we think because the needs for the EV drive motor fabricator is so great, we can apply pressure and then guarantee this person that they will be profitable, and that's something they can't do outside of China. And I think that the last slide is just some generic information. Pea Ridge has 3 rare earth deposits. The one is sitting on the surface. The next one is in the iron ore body, and every ton of iron ore we beneficiate, we get a certain amount of the same material, but highly purified and ready to go. And then the third are the breccia pipes, and they're quite famous. And there's Cheryl. Cheryl knows more about the breccia pipes than I do, that's for sure. Anyway, so that's pretty much everything I can do. At this point, I'd love to answer some questions and see where your interests are. Challenge me on some points. That would be fun.